Okay, guys. So, looking at problems 1 through 5, are there any questions on any one of these here? So, evaluate each expression for -2 and 3. So, for 1, we do 16 to the -2 plus 5. And see what we get, and as well as 16 to the 3 plus 5. So for the first one, we can type it in as 16 to the -3 plus 5 and get 256. Then we can also do 16 to the 3 plus 5, 429, 496. 429, 496, 7296. Because for 1 through 5, we're evaluating each one for -2 and 3. So we should get 2 values for each. Yes, thank you. 4096. Yeah, it should have been a lot larger than that, 4096. Any other questions on 1 through 5? Are we good with problems 1 through 5? Yes? Question 6 through 11, determine whether each is exponential growth or decay. So for number 6, would this be growth or decay? Because the fraction is greater than 1. 7 would be decay because our base is less than 1. Number 8, growth because the base is greater than 1. Number 9 would be growth, and that's because since we're dealing with e, the exponent is positive. If the exponent's positive, it's growth. And with e, if the exponent's negative, then it is decay. And the last one is growth, because the exponent is positive. Any other questions on page 1? We're good with these here. Rewrite the equation in exponential form. So log base b of x equals y is true if and only if b to the y is equal to x. Now, I have a feeling throughout the course of this chapter, when I wrote this general statement, I may have been switching x and y, but it really doesn't matter. And what I mean switching it is that I wrote the first one as log base b of y equals x is true if and only if b to the x equals y. But this is true however we have it, as long as it stays in the correct form. So if we look at this first one here, log base 9 of 6,561 equals 4, an exponential form would be what? 9 to the 4th is equal to 6,561. How about number 13? $78,125, yep. And that's it. Now we could apply one of our properties, especially with solving, because if I wanted to solve this here, I would put both sides to the 1/7, which is telling me 2,401 is equal to 1/7 to the negative fourth. But it's still doing the same process. And last but not least, 15 to the first is equal to 15. Any questions on 12 through 15? Are we ready for the next set? So what would 16 be? Because remember, with natural logs, the base is understood to be e. With logarithms, log, if the base is not written, it's understood to be 10. So the next one would be what? E to the is equal to 6. Because ln of x equals y is true if and only if e to the y is equal to x. So here e to the y is equal to 71. And lastly, e to the 9th is equal to x. Any questions on any of these here? Any questions on 1 through 19? Rewrite each equation in logarithmic form. So how would we go about this for 3 to the 4th is equal to 81? We'd say what? Log base 3 of 81 is equal to 4. How about for the next one? It would be log base what? 1/5 of 1 over 125 is equal to 3. And lastly, we would have log base 125 of 25 is equal to 2/3. Yes. Yes. Any questions on 20 through 22? 23, how would we rewrite this? Of x is equal to 4. 24 would be ln of 27 is equal to y. And lastly, ln of y is equal to x. Any questions on 1 through 25? And again, the properties for these here work the same as the last ones. We're just going from one to the other. Exponential to logarithm, or logarithm to exponential. We good with these here? Evaluate each logarithm and round to the third decimal, round to 3 decimal places. So for the most part, we can plug these into the calculator. For the first one, we can use the graphing calculator and say math log base of 5 of, I believe it was 1 over 125, correct? And if we type this in, we get -3. And we do the same thing with log base 9 of 2,187. Is 3.5. One, two, three, 4. I believe if we type this next one in, we should get -5. Now, since it is log base 10, we can just use 10, or just log 0.1234, 1. Yep. ln, we can just type in the calculator as ln, so we can do ln of 27 and get 3.2958 or 3.296. And 30 and 31, we just type it in exactly as we see it. Any questions on these here? We ready for the next set? We're not worried about expanding or condensing. I'm not going to have those on the test. The properties of it will be there, especially exponent properties, multiplication, division, but it's going to be more in the use of solving than it is actually expanding or condensing. Which one do we want to look at first? 40 or 41? 40. Whenever we look at these here, there's different ways to approach them. But the main thing is seeing if we can get the bases to be the same. Because the only ones where we've covered, or the only ones that we have covered where we have variables and two exponents, is if the bases can be the same. Well, 2 is as simplified as it gets. However, can we rewrite 2, or 8, as 2 to a power? 2 to what power is 8? 3, yes. 2 to the third is 8. So I can replace 8 with 2 to the third. Now it tells us the one on the right is, or one on the left is still 2 to the 2x plus 15. The one on the right side, we multiply through by 3. 3 times x is 3x. 3 times negative 7 is negative 21. Because our one-to-one property states if the bases are the same, then the exponents must be equal as well. Now at this point here, we just need to solve for the value of x. So the first thing we can do is we can minus 3x from both sides, yes. If we subtract 3x from both sides, 2x minus 3x is going to be negative x. Plus 15 is equal to negative 21. Then we can subtract 15 from both sides, telling us negative x is equal to negative 36. And last but not least, we need to multiply or divide by negative 1, telling us x is 36. Any questions on how we got to this here? Because we can plug it back in at the very top. 2 to the 2 times 36 plus 15. And we get this massively big number. Now we can do 8 to the 36, what is it, plus 7? Minus 7. And we see that even though both numbers are massively big, we have the exact same number. So they work out to be the exact same thing. So x equals 36 is the correct answer. Any other questions on 40? Questions on 41? We feel good with 40 and 41. Because 40 and 41 are the same, we just need to get the bases to be the same. And once they are, we'll set the exponents equal to each other. Any questions on these here? We ready for the next two? Questions on 42 or 43? The bases are the same, so the exponents must be the same as, well, really another way we can think of it is I apply ln to both sides. So the exponent would come out front and ln of e is 1. The other side, the exponent comes out front and ln of e is 1, leaving us with 4x plus 7 is equal to 6x minus 35. Now we just need to get x by itself. So I'm going to subtract 4x from both sides, telling us 7 is equal to 2x minus 35. At this point here we can add 35 to both sides, telling us 2x is equal to 42. And last but not least, we can divide both sides by 2, telling us x is 21. Any other questions on 42? We just need to get e to the x, or e by itself first, so we can add 7 to both sides. Telling us that 2e to the x is equal to 12. And we would divide by 2, telling us e to the x is equal to 6. Then what can we do next? We need to get rid of e, so we can apply the natural log to both sides. Because with the natural log of e to the x, we can move the x out front. And the natural log of e is 1. So it just leaves us with x is equal to the natural log of 6. So x is the natural log of 6, or if we type it into the calculator, 1.7917 or 1.792. And that's it. Any questions on either one of these here? Questions on 44 or 45? Because 44 is almost the exact same problem as 44, or 43 and 44 are essentially the same problem. Get e by itself, apply the natural log, and then solve for the value of x. Questions on 45? Well, we do have the number with a variable and its exponent by itself, so we can apply a log to both sides. Now, what log will we apply? Log base what? 7. Log base 7. Because when we apply a logarithm, one of the properties of logarithm says we can move the variable out front. So it'd say we have x times log base 7 of 7 is equal to log base 7 of 3. Now, what is log base 7 of 7? 1. So that is 1, leaving us just x is equal to log base 7 of 3. Now, in the graphing calculator, we can go math. Log base 7 of 3 is 0.565 if we're rounding to the nearest third decimal place. Any questions on 45? Any questions on anything we've done so far? Questions on 46 or 47? or either one of those that you want to see work. We good with 46 and 47? Okay. Questions on 48 or 49? Or either one of those that you all want to see worked? (49). Now, since the two logs, we only have two logs and they're equal to each other, there's nothing else, we have our one-to-one property. So what that states is that what's inside the logs has to be equal. So 12x minus 9 is equal to 3x. At this point here, we need to get x by itself. So we can subtract 12x from both sides, telling us negative 9 is equal to negative 9x. And last but not least, we can divide both sides by negative 9, telling us x is equal to 1. And that's it. If the logs are the same. Because, I mean, what we could think of it as is putting both sides to the base, because both of the logs are base 10, so we can put both to the base 10. So these would cancel, telling us that 7x plus 3 is equal to 38. We can minus 3 from both sides. These would cancel. Minus 7x is equal to 35. Divide both sides by 7, telling us x is equal to 5. Now, the main reason this works for both of them is that we only have two logs. We don't have anything else, and they're on opposite sides of the equal sign. Any other questions on 48 or 49? Questions on 50? Mm-hmm. We only have an exponent, a variable, and one exponent, so we're going to apply a log to both sides. Well, what base would we use? Because on the one side, this entire thing would move to the front. So we'd have 6x plus 2 times log base 11 of 11 is equal to log base 11 of 38. Log base 11 of 11 simplifies to 1, leaving us with 6x plus 2 is equal to log base 11 of 38. Now at this point here, we're going to subtract 2 from both sides, telling us 6x is equal to log base 11 of 38 minus 2. And last but not least, we're going to divide both sides by 6, telling us x is equal to log base 11 of 38 minus 2 over 6. And at this point here, we would type the whole thing into the calculator. And again, we use log base 11 because we wanted this to simplify. Now, if they had two different exponents, like the first one we solved, we can't just apply two different logs because we have to apply the same one to both sides. Or we have to apply the same base to both sides. We can't apply two different bases. Questions on 51 or 52? Either one of these that we want to look at. 52. To get rid of the logarithm, because log is by itself, we need to apply it to a certain base. What base would we apply to this here? What is the base for natural log? Because those would cancel, telling us 6x minus 2 is equal to e to the 7th. At this point here, we just need to solve this for the value of x. So the first thing we can do is add 2 to both sides, telling us 6x is equal to e to the 7th plus 2. And last but not least, we'll divide both sides by 6, telling us x is equal to e to the 7th plus 2 divided by 6. So we're rounded to the third decimal place, so we'd have 183.106. Yeah, if it says to the nearest third decimal place, we want to the nearest third. But I would highly suggest listing both. Any other questions on 51 or 52? Questions on 51 or 52? Questions on 53 or 54? Questions on 53 or 54? We feel good with 53 and 54? 53. So the first thing we need to do is get the logarithm by itself. It is by itself. Now we need to apply a base to both sides. What base would we apply? 9, because it is log base 9. Because our property states b to the log base b of x is equal to x. These will cancel out, leaving us with 2x plus 7 is equal to 9 squared. And now at this point here, we need to solve for the value of x. So the first thing we can do is subtract 7 from both sides, telling us 2x is equal to, well, 9 squared is what? So we have 81 minus 7. 81 minus 7 is 74. And lastly, we can divide both sides by 2, telling us x is 37. Any other questions on 53? Questions on 54? We feel good with 54? Because again, get the logarithm by itself before we can apply the base. Questions on 55? We can only have one, for us to be able to solve, we need one log and everything else on the other side. But if I have two logs being added together, I can rewrite it as a single log with what's inside being multiplied. And after we rewrite it as a single logarithm, we can put both sides to the base. Here, because it's log base 5, we're going to put both sides to the base of 5. Those will cancel, leaving us with x plus 4 times x plus 1 is equal to 5 squared. Well, what is 5 squared? 25. Now, this part here, we can multiply this out. X times x is x squared. X times 1 is going to be plus x. 4 times x is plus 4x, and 4 times 1 is 4. Now we can combine like terms. We'll have x squared. X plus 4x is 5x. plus 4 is equal to 25. Now, because we do have a quadratic, we need to get this equal to 0, so we can subtract 25 from both sides. Minus x squared plus 5x minus 21 is equal to 0. Any questions on how we got to this point here? Now, at this point, we could graph this or factor it or use the quadratic formula. I'm going to go on and just graph it. X squared plus 5x minus 21, graph. Make sure I wrote that in right. Okay. Yep. Well, it doesn't have nice points. So we need to actually use the quadratic formula for this. Our negative b plus or minus the square root of b squared minus 4ac all over 2a. Most all the ones on the test should work out nicely, but this one here does not. Yes. So at this point here, we're going to plug the values of a, b, and c, and well, b is positive 5, so we have negative 5, plus or minus 5 squared minus 4. A is 1, c is negative 21, all over 2 times a, or 2 times 1. Now the first thing that we can simplify is the negative 5 is just negative 5, plus or minus square root over 2. So we can type all that into the calculator and see what we get. So we can say 5 squared minus 4 times 1 times negative 21, and we get 109. So from the quadratic formula, we get x is equal to negative 5 plus or minus the square root of 109 over 2. Now we have two answers. Fraction. Negative 5 plus second square root 109 over 2 is this, or approximately 2.720. And we can do the same thing, but this time the radical will have a minus in front of it, which tells us that it's negative 7.720. If we plug it back in and check it, the positive one will work, the negative will not. Any other questions on these here? Questions on 56? We feel good with 56? Okay. Questions on 57 or 58? 57. So the first thing we need to do is get the logarithm by itself, and for this one here, the logarithm is already by itself. So we can put a little line, because we know what's inside the logarithm has to be greater than 0, because if whatever's inside the logarithm is 0 or negative, we do not have a solution for that. So we do need to solve this here. And this lets us know that x has to be greater than 1. Okay. Now that we have this, we can go on and actually start solving the problem here. Now, since the natural log is already by itself, we can put both sides to the base of e. because e and ln will cancel, telling us x minus 1 is going to be greater than or equal to e to the 9th. Then what do we need to do next? We need to add 1 to both sides, telling us x is greater than or equal to e to the 9th plus 1. Now we do need to plug this into the calculator and round to the third decimal place. So e to the 9th plus 1 is 8,104.084. Do we need to add the restriction in? Because we said what? X had to be greater than 1, yes? X being greater than or equal to 81,004, will that ever not be true? Will it never not be greater than 1? No. So we don't need it because there's no way that X could even be 1 and this statement still be true. So we don't have to add the restriction. Because if the values of X were approaching 1, then we would need it. But they're going away from 1, so we don't need it. Any other questions on 57? Questions on 58? So what would we do first? Well, what's inside of it cannot be 0. So x plus 2 has to be greater than 0. So we would minus 2 from both sides, telling us x has to be greater than negative 2. Now the first thing we can do is put both sides of the base of 7, because those two would cancel, telling us x plus 2 is less than 7 to the 4th. Well, we can wait to the end to simplify it, because the last thing we need to do is subtract 2 from both sides, telling us x is less than 7 to the 4th minus 2. 2,399. Now we don't have to go to the third decimal place because there is no decimal place. So we'll just have this here. Are the values of x going towards negative 2 or away from it with our solution? With x being less than 2,399. Are they going towards negative 2 or away from it? So plug negative 2 in for x. Is negative 2 less than 2,399? So is it going towards negative 2? Is negative 2 less than 2,399? Are you sure? Which number is bigger? Negative 2 or 2,399? So is negative 2 less than 2,399? Yes. So do we need our restriction? As you're overthinking it, is negative 2 less than this number?
Which one does the alligator want?
It's negative 2.
Or 2,399.
Is this a true statement? Then we need the restriction. Is this a true statement? Because so we don't need it.
Okay.
Questions on any of this here?
No.
Questions on 59 or 60? Questions on 59 or 60? Which one? 60. So again, the first thing we need to do is get the logarithm by itself. So we're going to divide both sides by 5, telling us log base 7 of 4x is greater than or equal to 332. Now at this point here, we're going to put both sides to the base of 7. Those will cancel, telling us 4x is greater than or equal to 7 to the 32nd.
Colton, John, and Allison failed. Come to the office. Colton, Allison, come to the office.
And last but not least, we're going to divide both sides by 4. Now we didn't mention it at the start, but this here 4x still has to be greater than 0. So really x has to be greater than 0. And with this here, 7 to the 32nd over 4, x is greater than it, so we don't need the restriction because it's going away from it. So the only times we really need the restriction if x is less than whatever number we have, being that number. Yeah. If it's less than it, we need the restriction. If it's greater than it, we don't. And if it's exponential, we don't need it anyways. Yeah, because 64 doesn't need it. Fix it. Questions on 59 or 60? Let's look at 62. The first thing we're going to do is apply log base 3 to both sides, because those two, log base 3 of 3 will simplify out, moving the exponent out front, telling us 4x minus 5 is greater than log base 3 of 108. Now at this point here, we need to get x by itself, so we can add 5 to both sides, telling us 4x is greater than log base 3 of 108 plus 5. Now last but not least, we can divide both sides by 4, telling us x is greater than log base 3 of 108 plus 5, all divided by 4.
Colton Jones, please come to the office. Colton Jones, please come to the office.
Now at this point here, we'll need to plug this into the calculator to get our answer. Hold on. Any questions on any of this here? One thing you definitely need to look over is our change of base. Because log base b of m is the same as log of m over log of b. So log base 7 of 4 is going to be the same as log of 4 over log of 7. This is also true with the natural log. So for this one here, we could rewrite it as the natural log of 4 over the natural log of 7. Your test is tomorrow.